Tonight is Saturday evening, September 9th. It's about 8:24. The sky is still got a hint of blue in it. So I don't expect sky dark to be for another 10 or 15 minutes. We of course are looking at Messier 27, but we're looking at Messier 27 using imaging parameters that I associate with a 12-inch telescope. Parameters are 64 flood and 36 AGC decibels. So the idea for tonight is to see if we can balance between deep sky depth and image quality. Besides, I have to take a break from the NGC series. They're getting far too east and I have to stay up far too late to capture them near culmination. So once again, Dumbbell Nebula at 64 flood and 36 decibels of AGC. In order to get this next view, I had to flip the scope equatorially. Not anything I really wanted to do, but it centered up reasonably well. And those of you who have followed this NGC series, as well as other images I've captured over time, recognize this as Messier 8, the Lagoon Nebula. It is just a couple of degrees past culmination. However, as mentioned, we're now operating at settings that I roughly equivalent with that of a 12-inch scope. Let's go ahead and look at some of the other nebulae before we move on. Here's our 12-inch view of Messier 20, the Trifid Nebula. Not bad. One of the things about operating at slower speeds, everything should sharpen up a little bit. The exposure times are about, let's see, 124 was about 2.5 seconds. We've cut it in half, so now we're operating at about 1.25 seconds of exposure times with 6 iterations. And it should gather enough light to see galaxies overhead down to about magnitude 15, which we'll hopefully check for later on. But so far, in terms of culminating nebulosities in Sagittarius, the views are just fine. Okay, here we have a decent view of Messier 17, the Swan Nebula. We're seeing good color, nice texture, fullness of nebulosity. So far I'm thinking to myself, 12-inch settings aren't bad, except I would miss those 16th magnitude galaxies. The Swan. Normally at 128 flood, it takes about 40 seconds to get a final image after all 6 stacks of 2.5 seconds plus image stabilization. Figuring this will be cut in half here, but the price you're going to pay is about 1.5 magnitudes of reach. At 128 flood, we could easily make out the Pillars of Hercules in the Eagle Nebula. However, I am not really able to see much of the nebulosity in this low luminous density nebulation. I'll look for them tomorrow. It would be unfortunate if we weren't able to see them through the 12-inch settings, but at least it would set some kind of a boundary for me to be thinking about in terms of future use of these settings in order to get better, more highly aesthetic and quicker image renderings of deep skies. Okay, now we're back to Messier 27, the Dumbbell Nebula. Look for that central star of magnitude 14.1. It should reveal itself. However, I don't expect to see the frontiers of the more football shape of the 2 and the 7 o'clock position, but I'd like to see a nice frontier on the extremities of the hourglass shape that makes up the dumbbell. That's our hope anyway. Now I'm going to go on to this next study, but we may not capture it because it may be in the roof try, NGC 6888, the Crescent Nebula. Okay, we're pointing almost straight up to the crescent, and in this particular position at the zenith, we may be getting some aperture masking by the roof trisections. So any hints of the crescent would be appreciated. And I think I'm seeing a little bit of nebulosity in about the 10 o'clock position. And that's good enough for me, although I've seen it at the eyepiece of a 6-inch telescope in the past. Very small segments of the crescent. But there's a start-off image. And now we're going to go on to other studies, all in the 12-inch and smaller telescope range. And we'll see how they look operating at these parameters. What you're seeing on the screen right now, taking form, is a globular cluster, Messier 55. It's in Sagittarius. I'll give you some idea of the sky position and characteristics. Messier 55 is rated for a 5-inch telescope. In other words, a 5-inch telescope should show a glowing ball with faint, maybe 13th magnitude stars around the perimeter, its brightest stellar components. The cluster itself is magnitude 6.3, 19 arc minutes in size, 17,300 light years distant, and is at minus 31 degrees. So basically, we're losing an awful lot of magnitudinal reach simply due to sky position, as I've explained in last night's NGC video. Here we have Messier 75. You're seeing a faint sprinkling of its brightest outermost stars around a very dense cluster core. This particular globular cluster is rated for an 8-inch scope, so it's giving what I would consider to be somewhat of an 8-inch view right there. There are some resolved components in the perimeter, but the bright central core is the interesting part. The cluster is magnitude 8.6, very small, 6 arc minutes. There's a reason why it's so small. It's 67,500 light years distant, and one of the reasons we're not resolving as many stars is it's minus 22 degrees in declination. But that's a pretty sharp view. Although due to its declination, I think you need a larger scope, a larger, higher sensitivity setting in order to be able to reveal more of this cluster than the 12-inch settings I'm currently using. Here we're seeing Messier 71. Give you some data on it in a second. It's up well up into the sky's middle third. Globular cluster in Sagittum, magnitude 8.3, 6.1 arc minutes, a mere 13,000 light years distance, so this one's very small, plus almost 19 degrees in terms of sky position declination. Easily resolved. Messier 71 is rated as a 8-inch aperture telescopic study. Rated as a 12-inch study, so basically these parameters we have set up here. NGC 6823 is a nebula in an open cluster of Vulpecula. Magnitude 7.1, 12 arc minutes, some 30 stars, the brightest of which are 8.8. It is a condensed class, Roman numeral 1, disparate magnitude, class 3, open cluster, 10,400 light years distant. Now, I'm wondering if the rating is based on the nebulosity, and I cannot tell you whether or not any is present on the screen. We'll have to look at it tomorrow. Here I am staying with things that are pretty much culminating right now. That's basically the NGC 6800 series. This is 6804. I've already imaged it using the 18 to 20 inch settings previously. This is Planetary Nebula, and I'll give you the spec on it. You should be able to watch it develop on the screen. It's fairly large, so it should make its presence well known if we have enough light gathering capacity. As you see, 6804. So what I plan to do is keep skipping through the 6800 series, finding interesting studies that we can look at using the 12-inch parameters. As you see, 6804, Planetary Nebula Aquila, magnitude 12.4, 63 by 50 arc seconds, roughly around 1 arc minute. The central star is magnitude 14.2, it's 5,600 light years distant, and it is 10 degrees above the celestial equator. Hope we got a nice view. I think we have right about there. Let's watch this one formulate on the screen. It's NGC 6814. Now you look at the screen and watch what develops, and I will tell you in a few seconds what the parameters are. Obviously, I'm skipping through the 6800 series, looking at them for the most interesting possible studies for comparo purposes. 6814 is a galaxy in Aquila, magnitude 11.2, largest 3.5 by 3.5 arc minutes. It's a spiral with a large bar, lowercase bc, and a ring, 70 million light years distant. However, it suffers from being minus 10 degrees declination. I'm hoping it is forming on the screen. It should form fairly quickly. At these settings, we should be able to see the full object fully rendered in about 20 seconds. NGC 6835 is a galaxy in Sagittarius, magnitude 12.5, 2.4 by 0.7, slightly oblate, not quite edge-on spiral with a large bar, 71 million light years distant. Suffers from the fact it is minus 12.5 degrees in declination. I'm hoping we are getting some kind of a view, and I suspect it's right about there, but we'll check it out tomorrow. Well, a few very faint steps, and we're at NGC 6836, another galaxy in Sagittarius. This one's almost magnitude 13, 12.9. More face on, 1.7 by 1.5 arc minutes, a spiral with a large bar, 72 million light years distant, and minus almost 13 degrees in declination. NGC 6857 is a nebula in Cygnus. Magnitude 11.4, excuse me, 0.8 arc minutes in size. It says it has a star of magnitude 14.3 within it. It's an emission type nebula, plus 33 degrees, so well positioned in the sky. We should get a decent view. I'm not sure if we are, but I suspect it is right about here on the screen. NGC 6883 is another nebula in open cluster in Cygnus. Magnitude 8, some 15 arc minutes in size, 30 stars. It's a class 1. The stars are pretty much all this tightly compacted and just widely distributed. Class 3 in stellar magnitude, 4,500 light years distant. We're pretty much pointing straight up in the sky, so we should get a good view. Hopefully we'll see that nebulosity. NGC 6901 is a galaxy in Aquila. It's plus 6 degrees above the celestial equator, magnitude 13.7, 1.1 by 0.4, so kind of edgy on. spiral with a bar, 216 million light years distant. What I'd be looking for here is being able to detect it at all, because typically galaxies with a scope that's able to see 15th magnitude stars can only really discern 14th magnitude galaxies among them. So it'll be an interesting test tomorrow. This one is magnitude 13.7, but it has nice contrast as an oblate, 1.1 by 0.4 arc minute. Here we have another culminating galaxy, NGC 6903 in Capricornus, magnitude 11.9. So it should be 2.6 by 2.4 face-on spiral, lenticular type with a bar, 148 million light years distant. This one's minus 20, which basically would say that at minus 20 degrees we should be able to detect 12th magnitude galaxies with a 12-inch configured telescope. Let's hope we can see it. Okay, let's watch this one develop. NGC 6905, it'll be our Carpe Noctem view for the evening. I might look at the triangular galaxy though. What I hope we're seeing with NGC 6905 is a planetary nebula in Delphinus the dolphin, magnitude 12 and largest, 44 by 38 arc seconds. It's 5,700 light years distant with a central magnitude star of magnitude 14, 20 degrees up. So this should give us a good opportunity to characterize what can be seen through 12-inch settings on the Rev2 real-time imaging system with a 6-inch aperture semi-apochromatic refractor. Let's go have that look at Messier 33 and then call it Carpe Noctem. Okay, can't be sure if this one's centered up very... Oh no, we're looking at the eaves of the house. A little too early in the evening. Well, thank you folks. Carpe Noctem.